In this example, we're going to solve this radical equation. If you'd like to go ahead and give it a try, first pause the video and do so, and then come on back and we'll work the solution together. Alright, so looking at this initially, we have the square root of x minus 1 on the left side, and we have the fourth root of 8x plus 1 over here on the right side. What's nice about this equation is that there are no terms outside of the radical expressions. Okay, so that'll make our lives a little easier. Let's go ahead and start by turning each one of these radical expressions into having rational exponents, which means instead of being a square root, we're going to say this x minus 1 is raised to the power of 1/2. And again, that 2 is this square root right there. And the same thing on the right side. Let's take this 8x plus 1 and take him to the power of 1/4. And again, that's that fourth root right there. Okay, I like doing it this way because it helps us visualize numerically what's going on. So we have this fraction here that's 1/2 and this fraction here that's 1/4. So those denominators are 2 and 4. So if we were to get common denominators, it looks like that would be 4. So we can say x minus 1 to the power of 2/4 equals 8x plus 1 to the power of, well, 1/4, because that guy didn't change. Okay, so I like this denominators being the same here because this helps us visualize numerically what we need to do. So each side of this equation is being taken to the fourth root, right? But the inverse operation of that is going to be to raise each side of the equation to the power of 4. So we'll do that there and there. And what will happen is that these 4's cancel here and here. And what we're left with then is x minus 1 squared equals, well, just that 8x plus 1. So this is not too bad at all. So let's go ahead and square this left side. So it'll be x squared minus 2x plus 1, and that'll equal that 8x plus 1. Well, it looks like these 1's will cancel. And let's subtract 8x from both sides. And it looks like x squared minus 10x equals 0. Well, that's easily factorable. So we'll take the greatest common factor of x out. So we'll have x minus 10 equals 0. And so we have two factors, x and x minus 10. And I know if I'm multiplying these together and I get 0, well, then the 0 property of multiplication tells me one of these critters has to be 0. So let's go ahead and accommodate for both of them, and we'll set each factor equal to 0 and solve. Okay, that was easy enough. Well, 0. And this one will be x equals positive 10. So two possible solutions here. And again, why might I say possible solutions? Well, because when we raised each side of the equation to a power of 4, we kind of opened ourselves up for the possibility of having extraneous solutions. So what we need to do now is rewrite this original equation and plug in these possible values and see what works and what doesn't work. So we'll start with x equals 0. So 0 minus 1 is negative 1, so it's the square root of negative 1. Well, kind of have a problem here already. So when we do this, 0 here, 8 times 0 is 0, plus 1 is 1, fourth root of 1 is 1. So yeah, we can see this, this one's not going to work out. So x equals 0 is going to be an extraneous solution because we do not want to work with complex numbers here. We want to keep everything real. Okay, so how about x equals 10? Well, we plug 10 in. 10 minus 1 is 9. Square root of 9 is 3. Okay, and then 8 times 10 is 80, plus 1 is 81, and fourth root of that is 3. So that one works out. So we see that x equals 0 will be an extraneous solution, but x equals 10 will work, so that's going to be the solution for this original equation.